Very good morning to everyone. In this lecture, EC 8351 Electronic Circuit 1, Department of Electronics and Communication Engineering, third semester. In previous session, we have to discuss the biasing of the BJT and also the what are the DC load line and AC load line of the BJT configurations. Today we are going to discuss the stability factor of the BJT configurations and also the UJT configurations. First we have to discuss the stability factor of BJT configuration biasing. So first, what is a stability factor? So the definition, in order to compare the stability provided by these circuits, one term is raised called a stability factor, which indicates the degree of changes in operating point due to variation in temperature. That is called the factor. So the stability, we have to define the three different conditions. The first one, the stability is equal to the del ICO into del IC. That is a dou ICO divided by dou IC into the constant value of the base emitter voltage and beta. That is a ratio between the output side, that is a collector current into the collector leakage current. It is a ratio. So how the collector current we can produce it, what are the parameters, what are the input values are constant, that is a base emitter voltage is constant, and also the current amplification factor of the BJT is constant. In this term, the constant value of the base emitter voltage and beta, we can produce the output voltage. What is the output voltage? Collector emitter voltage. So that we can apply the collector emitter voltage, we can induce the collector current. So that current, we have to compare the actual collector current into the leakage collector current. It is a differentiation between the ratio. It is called the stability. The second one, S dash, that is the second stability factor of the BJT configurations. So the ratio between the base emitter voltage into the collector current in the constant value of the collector leakage current into the current amplification factor. So we have to we have to taken the ratio between the input voltage into the output current. What are the constant parameters? Collector current leakage and beta. It is the second condition of the stability factor. That is to improve the accurate output, stable output of the BJT configurations. In third stage, the S double dash, it is the current amplification factor, that is a ratio between the current amplification factor of the BJT into the collector current in the constant term of collector leakage current and beta, and base emitter voltage is constant. So the three different conditions we have to examine, we have to justify the stability factor of the BJT circuits. So now we can move to the equation of the stability factor S and S dash and S double dash. Here, for a common emitter configuration, collector's current is given. What is the common emitter configuration output current? That is IC. Collector current is equal to the current amplification factor into the base current plus the collector emitter leakage current. That is the output current is equivalent to the input current plus leakage output current. So here the leakage output current is independent to the current amplification factor, that is a 1 plus beta. So this is the equation 1.7.4. When the collector base leakage current, that is the input and output leakage current, changes by del ICBO, the base current changes by dou IB and IC, it changes by dou IC. So this equation becomes dou IC is equal to beta into dou IB plus 1 plus beta dou ICBO. So we have to simplify that the 1 plus 1 equal to the current amplification factor into the ratio between the input current and also the output current IB and IC plus the leakage current amplification factor 1 plus beta into the leakage current, that is a input to output both leakage current divided by the output current. Now we can simplify that equation to rearrange the conditions of 1 minus beta into dou IB by dou IC is equal to 1 plus beta into dou ICBO divided by dou IC. Now we have to justify the stability factor of the collector base leakage current into the collector current. That is 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 equal to the dou IC is equivalent to 1 plus beta, that is the current amplification factor of the output current, divided by the current amplification factor of the leakage current, that is a 1 minus beta into the base current divided by collector current. So here the equation can be considered as a standard equation for derivation of the stability factor of other biasing circuits. Here the fixed biasing circuits, that is the first biasing methods of BJT configurations, the stability factor S is equal to the base current is equal to the initial threshold voltage divided by the base resistance. Here the base resistance is changes by dou IB, so the threshold voltage and the base emitter voltage are unaffected. So the base current and divided by dou IC is equal to 0. Here the IC is not present in the equation. Substituting the value in the equation, the S equal to 1 plus beta divided by 1 minus beta into dou IB divided by dou IC is equal to 1 plus beta divided by 1 minus 0. So we have to consolidated the stability factor of this biasing, that is a fixed biasing circuits, the S equal to 1 plus beta, that is the stability is equivalent to the current amplification factor of the circuits. Now we can move to the stability factor S dash is a condition of the ratio between the base emitter voltage into the collector current in the constant value of the collector out leakage current into the current amplification factor. From this equation we have to take the output current, that is IC. So the IC is equal to the current amplification factor into the base current plus the leakage current amplification factor. Now we can simplify that equation. The dou IC divided by dou VB is equal to 0 minus R beta divided by RB plus 0. So in these conditions the base emitter voltage is the ratio between the stability factor of the collector current So we have to minus beta, that is a negative current amplification factor divided by the base resistance. So the stability factor S dash is equal to the minus beta divided by RB. Now what is the relationship? S and S dash is the relationship between is equivalent to the S double dash. So we have to know the S equal to 1 plus beta and S dash is equal to minus beta divided by RB. It is a multiplying numerator and a denominator of by 1 plus beta. We have to take the S dash is equal to minus beta S in divided by RB into the factor of current amplification factor, that is a S. So we have to minus beta divided by S minus beta into S divided by RB into 1 plus beta. So here the stability factor double dash is equal to the condition of the current amplification factor of the input and output side is a ratio between the collector current in the constant value of the input base emitter voltage and collector leakage current. So here the equation, the IC is equal to beta VCC divided by RB minus beta VBE divided by RB plus 1 beta plus 1 ICBO. So the condition of these S double dash is equal to IC divided by beta. It is a beta IB is equivalent to the IC divided by beta. So the IB is greater than the collector base leakage current. So what is the relationship between the stability and the stability double dash? That is S equal to 1 plus beta, S double dash is equal to IC divided by current factor. So multiplying the numerator and denominator by the current amplification factor of the input and output side 1 plus beta, we have to get the S double dash, that is IC into S beta into 1 plus beta. So we have to cumulate the functions of S double dash is equal to beta divided by RB. So in this session we are discussing the stability vector of BJT configurations. Thank you for watching this video.